Here I have a piece of glassware called a Venturi tube that's open at both ends. It's made of a tube that has a large diameter section that narrows down to a smaller diameter section and then expands out to a larger diameter at the end again. A small vertical tube is underneath each of the bottoms of each section. Here I have a section of clear plastic tubing bent into a U shape. The tube has a small amount of colored water in it. This plastic tubing can be used as a simple device to measure pressure differences. If the pressure is the same at both ends of the tube, the water level will remain the same on both sides of the tube. Even if I raise one side of the tube or the other, the level will remain the same. If the pressure is different on the two ends, the water level will rise on the low pressure side and drop on the high pressure side. We can see this if I suck on one side of the tube. Watch how the level of the water changes on each side of the tube when I suck on this end. This plastic tube is attached to the vertical glass tubes on the Venturi tube so that we can compare the pressure in the center small diameter section with the pressure on the large diameter end section. We can see that right now the pressure is the same on both these sections of the Venturi tube. I will blow through this end of the Venturi tube. When the air moves from the large diameter section of the Venturi tube into the narrow section, it will have to move faster in order to move the same volume of air through the smaller tube in the same amount of time. You're probably familiar with this phenomenon from using a garden hose. If you let the water flow out of the open end of a garden hose, the water flows out fairly slowly and you can only water plants that are close to you. However, if you cover part of the opening with your thumb, narrowing down the opening, the water flows out at a higher speed and you can spray the water farther away. What will happen to the height of the water under the small diameter portion of the Venturi tube? Will the height increase, decrease, or remain the same? Let's see what happens. The water level increases under the center, small diameter portion of the Venturi tube because of Bernoulli's principle. Bernoulli's principle shows that higher speed in a fluid corresponds to a lower pressure. Because the speed of the air flowing through the small diameter section is greater than in the large diameter section, the water level rises here where the pressure is lower and drops here where the pressure is greater.